I pointed out in the last section that we treat structural members with a really big aspect ratio as a flat area. We call those flat areas diaphragms. To predict how gravity load on a floor or roof diaphragm distributes to its supporting members, we make an assumption and an approximation. Gravity load typically acts as a uniform pressure on the diaphragm. So imagine that this floor is experiencing a uniform live load or dead load pressure. This floor is supported by three beams, which are then supported at their ends by columns. We can draw the loading on a slice taken from the floor. Uniform pressure means there is uniform distributed load on this slice. The beams are flexible, so they can displace vertically, but how much each displaces is a function of how stiff the beam is and how much load it gets. Therefore, this strip of floor is most accurately idealized as a member on springs. Performing analysis on this idealization is doable, but quite a challenge. Fortunately, the strip of diaphragm is typically way more flexible out of plane than the members supporting it. Therefore, it is reasonable to idealize the strip of diaphragm as being carried by supports that do not displace vertically, roller and pin supports. To be clear, we are assuming that the diaphragm is much more flexible out of plane than the members supporting it. For any diaphragm supported by more than two members, we have an indeterminate situation. We have more unknowns than equations of equilibrium, so we can't calculate the load on each support. That leads us to our approximation. If we treat each panel of the diaphragm as acting independently, we get this idealization, which is determinate. Each piece of diaphragm between supporting members we will call a panel. The result is that each strip of diaphragm is simply supported, which is determinate. The technical description is that we are treating the diaphragm as discontinuous over each supporting member. The way we build diaphragms, this tends to be a reasonable approximation. So to be clear, our approximation is that each diaphragm panel behaves independently of the other panels. We are ignoring continuity between the panels.